Let's look at the phrase perpendicular bisector. First of all, a bisector is something that cuts something else in half, exactly in half. Perpendicular means that it's at right angles. So we want to take the segment AB that has coordinates at -3, 4 and 5, 6, and we want to find the perpendicular bisector of that segment. So, like I said, bisector means to cut exactly in half, so we need to find the midpoint. And we can do that by averaging the x and y coordinates. So we get -1 for, +1 for the x coordinate. And then for the y coordinate, add 4 and 6, divide by 2, we get 10 over 2, which is 5. Not 2, 5. So we get a coordinate of 1, 5. Alright, but it's not enough to bisect it. We need a line that's perpendicular at that point. Well, to get a perpendicular line, we need a slope that's an opposite reciprocal. So let's find the slope of this segment. So it goes up 2 for every 1, 2, 3, 4, 5, 6, 7, 8 to the right. So the rise is 2, run is 8. We can reduce that to 1/4. You could have also just said go up 1 and then to the right 1, 2, 3, 4. That would get you 1/4 as well. So then for the equation we use point slope form. If you don't remember point slope form, the x1, y1 here is a point on the line, m is the slope, and then the regular x and regular y are just part of the equation. So let's plug into this equation. We get y minus the y value we found, which is 5, equals the slope, which was 1/4. We need a perpendicular opposite reciprocal. So if we're going to do a perpendicular, we need the opposite reciprocal. So we need to do -4 for that. And then we get x minus the x coordinate, which is 1. So that is the equation of the line. And we can leave it like that. You could convert it to slope-intercept form if you wanted to by distributing the -4 and then adding 5. That would be fine. For example 6, we're going to need to go into the book, so you may need to pause the video and look in your book and read the first paragraph there in example 5. I'm going to start diving right into the example, so read that before you continue the video. So in order to find the distance from the center to the circle, which is the radius, in order to find that distance, we need to know where the center of the circle is. And to find the center of the circle, we're going to use these chords that were given. If you don't remember what a chord of a circle is a segment that has endpoints on the circle. So those two red segments are chords of the circle. And also, if you don't remember from geometry, any two perpendicular bisectors of chords will meet at the center of the circle. So if we can find the perpendicular bisector of each of those chords and find where they meet, then we can find the center of the circle. And then we can use that to find the radius. So let's first work on finding the perpendicular bisectors. So let's start with the red segment on the right side, from 0 to 34, 34. So first of all, we'll find the midpoint, which means average x's, average y's, and we get the coordinates 17, 17. So that is the midpoint of that segment. To find the slope, we take rise over run, so that's 34 over 34, because it's going from 0, 0 to 34, 34. And so that makes the math a bit easier. We just take the x and y coordinates and essentially just divide them. So that's a slope of 1. So then go back to our equation, y minus y1 equals the slope times x minus x1. And we can plug into that. So we get y minus 17 equals, and then again we need an opposite reciprocal slope here. So instead of using a slope of 1, we use -1. Then x minus the x value, which is 17. Let's convert this to slope-intercept form. And so I'm going to distribute the negative here. We get -x and then positive 17. And then we'll add 17 to get y by itself. So we get y equals -x plus 34. That's how they get the first equation there in step 1. Then for the second equation, this is for the segment on the left, the red chord on the left. we're going to again average the coordinates. So if you average 0, 0 with negative 66, 22, you get negative 33, 11. So those are the coordinates of the midpoint of the chord on the left. The slope then, the rise is 22, run is negative 66. We can reduce that down to negative 1/3. But again, we want the opposite reciprocal. So we'll make it positive instead of negative, and instead of 1/3 we have 3. So this is the slope we're going to use. And we can say y minus the y value, which is 11, equals the slope times x minus the x value. Well, for subtracting negative 33, that's the same thing as adding 33. So I'll just write it as plus 33. Again, let's get it into slope-intercept form. So on the right side, I'm going to distribute and then add 11. So we get 3x plus 110, and that's how they get the second equation. Well, now we have a system of equations. And if you remember when we were looking at solving systems of equations in chapter 3, the solution to a system of equations is where the lines meet. So we have a line that describes each perpendicular bisector, and so if we solve this system of equations, we will find the point where those meet. We'll be finding the center of the circle there. That's where these lines meet. So let's solve this system of equations. I think it's going to be easiest to solve this with substitution. Because they're both already solved for y. This is why I got them into slope-intercept form. They're both already solved for y, and so we can very easily plug one into the other. And in fact, if you whichever way you plug one into the other, you should end up with this right here. So that is what we're going to solve now. All right, so we have, let's see, get everything with an x on the right side. We can add x to both sides. We get 4x plus 110. And then that leaves us with 34 on the left side. So then let's subtract 110 from both sides. And we get 4x equals negative 76. Divide both sides by 4. And we get negative 19. So that's the x-coordinate of the center of the circle. We need to now find the y-coordinate. So we'll take that x value of negative 19, and we're going to plug it into any of the equations. I trust that you can do that, so we'll skip that step. But you plug negative 19 into any of those equations, you should get 53. So then we have xy coordinates of 19, 53. So that is the center of the circle on the bottom right. Well, now we want to find the radius. All right, so the radius of a circle is the distance from the center to any point on the circle. So we could pick any of those 3 points and find the distance from the center to that point. Let's make our lives a bit easier, and we'll pick the point 0, 0. So we need to find the distance from negative 19 to negative 953 to 0. So let's go ahead and do that. A couple ways we could do this. We have, let's try that again. Oh, come on. There we go. Okay, so we have, let's see, what was it, negative 1953? Okay, so that's, we'll call it there. Negative 1953, that's good enough. And we're going to find the distance between that and the point 0, 0. So one way we could do this is with the Pythagorean theorem. So this is the negative 19, this is 53. Or again, you could just use the distance formula. Flip back to the last lesson for that formula. I'm just going to use the Pythagorean theorem. So we'll say negative 19 squared plus 53 squared equals, we'll call it, actually let's call it r, because it's a radius, r squared. All right, 19 squared is 361. 53 squared is 2809. That equals r squared. Add those together, take the square root, and you should get, let's see, you should get about 56.3 for the radius. But Oh, I guess actually we're asked for the diameter, not the radius. But the diameter is twice the radius, so we just multiply that by 2, and we get approximately 112.6.